Okay, today we're going to have a look at finding the equation of an absolute value function. With an absolute value function, if you've got the sketch and you're trying to find the equation, what you have to do is you have to visualize the steps that have been taken in order to get to the final function. So when you look at the green function here, we have to think about what steps have happened in order to get it to this position. Okay, if I'm looking at this, it could have been originally a negative parabola, or it could have been a positive parabola. It actually doesn't matter. Both would be correct solutions. It's just happened in different ways. Okay, so when you're looking at a parabola, when you're looking at an absolute value function, you have to imagine all the steps that it could have taken place. So the first thing that I look at, I see that my absolute value function is sitting well above the x-axis. So that means after it's been absoluted, it's actually been shifted up. Okay, so that's probably one of the last steps that was taken. Okay, so it's been moved up above the x-axis. So the first thing I'm going to do is I'm going to re-sketch it as if it had just been absoluted. I'm going to shift it back down by 2. Okay, so I'm going to draw in all the important points that I can see. All these points that I can see, I'm going to just mark them in, and I'm going to use them to help me figure out what the step before this final step was. I'm going to move all of these points down by 2. Shifting all of these important points down by 2. Down by 2, down by 2, down by 2. And I'm just going to do a quick sketch. It doesn't need to be perfect. It's just giving you some idea of what the function looked like just after it had been absoluted. So now I'll look at the red curve, and this is a function that's just been absoluted. Once again, it could have been a negative parabola, or it could have been a positive parabola. I'm going to look at it and consider it as being a positive parabola. So what we have to do is that when we have to look at it, we have to imagine, well, what did it look like before it got absoluted? All of these points that are in the positive section of the y-axis would have been in the negative. That's what it means to be absoluted. They would have been flipped up. So what I have to do is I have to flip them back down. I have to change them so that they're now back in their original negative position. So that positive 1 becomes a negative 1. This positive 3 becomes a negative 3. And this positive 1 becomes a negative 1. And then all we have to do is we just have to fill the lines in again. All of this section of the red function that's in the positive section of the y-axis is fine. That's going to stay there. None of that changes. Okay. Okay. So now I've got the blue function. I can look at that now, and I can look at that and I can say, yes, that is a complete parabola. That parabola I can solve. So what we have to do is we have to look at all the important key points. I could actually use the grid line to be able to figure out some of the values, but I'm going to solve it algebraically as well. So my turning point down here is 2 and negative 3. So in my original function, one thing that we haven't done, we need to label our functions so that we can let our audience know our thinking and processing steps. So I'm going to call the blue function function number 1. You could also call this something like g of x to let your audience know that it's a different function to what you're going to get to in the end. The red function, I'm going to call that function number 2 because that's the second step that's happened. You could call that a different name like h of x. And the green function, the final function that we have, I'm going to call that function number 3, or f of x, the final function that we're going to be dealing with. Okay, so that just means that our audience can keep up with where we are as we solve each of the things. So I look at the first function, I know that h equals 2, k equals negative 3. And I've got y equals a, x minus h squared plus k, y equals a, x minus 2 squared minus 3. Now in order to solve the a value, what I'm going to do is I'm going to use this point here, this intercept point, because I can see that really clearly. However, I could also use the initial sketch. Have a look at this here. Up in this initial sketch, because it's got a nice grid line, I couldn't do this if I couldn't see the grid line. If I go across one, in order to get to that first point, I have to go down a half. Now, if that would flip that over, if we come and look at what that looks like on function number 1, okay, across 1 up a, across 1 up a half. Now my drawing isn't perfect, but I can look at the initial drawing on that grid line and I can see that that's down a half as well, so that matches up. So I know straight away that my a is going to be a half, but I'm just going to prove that to myself algebraically first. I'm going to use the point 0 and minus 1. So I'm going to substitute that in and see what we get. So we get y equals a, oopsie daisy, we know the y value, we need to fill that in. Okay, sorry about that. Okay, so we go negative 1 we're going to fill it in and we're going to go negative 1 equals a, 0 minus 2 squared minus 3. So add 3 to both sides, so we get 2 equals a, and the square root of minus 2 is 4, and then we divide that through, so we get a equals a half. Now I could see that graphically, but it's also nice to prove that algebraically. So therefore, in this case, our function number 1, which was g of x, is a half a minus 2 squared minus 3. So that's function number 1. Now we step through to function number 2. Function number 2 was that same function, but it was absoluted. So I can say that function number 2, which we called hx, you could keep calling them y's, it doesn't matter. Just by having that labeling with the function number 1 and function number 2 means our audience can tell that they're different functions. That's the absolute value of a half x minus 2 squared minus 3. And to get the final function, which is our green function, function number 3, which I'm calling fx, it's that absoluted function, it's h of x, but it's raised up by 2, it's lifted up by 2. So what I do is I'm going to say f of x is equal to a half, or even better, x minus 2 squared over 2 minus 3 plus 2. And that's that final absolute function. So that's how you go about finding the equation of an absolute value function. I hope that helped. Let me know if you need anything more on this sort of stuff, and I'll talk soon. Bye.